Okay, so today's topic is a review of the quadratic formula and the discriminant. This can be found in chapters 9-6 in your textbook. So as a quick review, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And if you remember, I posted some fun songs to help you remember that formula. The discriminant is the part that's underneath the radical symbol, so just the b squared minus 4ac part. We use the discriminant to determine how many solutions a quadratic has without having to do the entire formula. And then for both of these formulas, we need a, b, and c, and we get those from the standard form of a quadratic, which is ax squared plus bx plus c. Okay, this lesson's classwork is page 393 through 394, those selected problems. There are 3 challenge problems, and then the exit ticket is 2 problems that need to be turned into me, Miss Edwards. You can turn them in through Schoology, by email, or by sharing the answers with me through Drive. Okay, so for these ones, since it's a review of the topic that we did in the last lesson, I'm not going to go through every single problem with you, but there are a few that I've selected that I want to review because they're going to help you. So number 22 is just a normal equation that you would use the quadratic formula for. But when you get to number 24, if you notice, it looks a little bit different. And the difference is it doesn't say equals 0. So in order to solve this one, we have to get the right-hand side to say equals 0. So this negative 3 has to move. So to move it, I'm going to add 3 to both sides. And since 3 is a constant, I have to add it to the constant that's on the other side. So I'm going to add it to the 5. Okay, because they are like terms. So my negative 3 and my plus 3 cancel out. So I should have negative x squared plus 9x plus 8 equals 0. Now that it's in the correct format, now I can solve using the quadratic formula. So we have to determine what a, b, and c are. So in this case, my a is equal to negative 1, my b is 9, and my c is 8. And those are the numbers that I'm going to substitute into the quadratic formula. Okay, so remember, when I put things into the quadratic formula, I'm going to make sure that I put the values I'm substituting in parentheses. So in my formula, it always has the opposite. The opposite of what? The opposite of b. And in this case, b is our 9. So the opposite of 9 plus or minus the square root of b squared, which we already said was 9, minus 4. Our a value and our c value go next. So a is negative 1 and c is 8. All over 2a, which we said was negative 1. Okay, if you remember, in Schoology, I do have a template that you can use. It already has those spaces for you, and all you have to do is substitute the correct numbers in. So if you're struggling with where the numbers go or writing it all out, feel free to use that template. Okay, so we're going to solve this in 4 chunks, just like we did the last time. So the first chunk we're going to solve is this negative 9, or the opposite of 9. Well, we know the opposite of 9 is negative 9, plus or minus square root. And then inside the radical, the part that we can solve first will be the 9 squared. So 9 squared is 9 times 9. Well, that's 81. All right, the next piece we can solve is everything else that's in there. And remember that negative goes with the 4. So we're going to do negative 4 times negative 1 times 8. Okay? Negative 4 times negative 1 is positive 4. Positive 4 times 8 is 32. So positive 32. Sorry, that's green. I meant for it to be red, but okay, all over. Now we can worry about our denominator, which is 2 times negative 1. So 2 times negative 1 is negative 2. Okay, so the next thing we can do is we can simplify what's under the radical. So I have negative 9 plus or minus the square root 81 plus 32 gives me 113 over -2. So 113 is not a perfect square, so I'm going to leave it like a radical, but we know that we're going to have two problems we have to solve from this point. We need to solve -9 plus or minus the square root of 113 over -2. And then we also have to do the subtraction of that. Oh, sorry, not minus, plus. The second one would be -9 minus the square root of 113 over -2. You can only do one operation at a time. That's why we have to split it into two. So I can type this in my calculator. If you're typing it in, I recommend putting parentheses around your top. The reason is that way it will do the numerator first, and then it will take that answer and divide it by -2. If you don't, it'll take the square root of 113 and divide that by -2 and then add -9 to it, which will give you the incorrect answer. So for both of these, I recommend putting the numerator in parentheses if you're going to leave it like a radical. Okay, so if we do this, -9 plus the square root of 113 divided by -2, you should get -0.82. I round just to the nearest hundredth. And then my second answer is going to give me 9.82, again, rounded to the nearest hundredth. So these are my two solutions. Okay, because 113 was not a perfect square, I knew both of my answers are going to involve decimals. Okay, the next problem that I want to go over is number 32, because the other ones are all the quadratic formula. They look just like the one we just did. Just make sure that everything is on the left-hand side before you start. But number 32, this time it asks us for the discriminant. Okay, so the discriminant, remember, we need that b squared minus 4ac part. So looking at this, I'm okay because it's in standard form. Okay, it has equals 0 on the end. So right away, I can determine that a is equal to 5 because that's in front of the x squared. B equals -20 because that's in front of the x. And C equals +20 because that's my constant. The equal 0 is not a part of the A, B, and the C. Okay, so I'm going to substitute into this equation right here. So my B is -20 squared minus 4, and then I have A times C. Well, we know our A is 5 and our C is 20. Okay, -20 squared, that's like saying 20 times 20 because we know a negative times a negative is going to give us a positive. So that's 400. -4 times 5 is -20. -20 times +20 gives me -400. So my answer is 0. This is my discriminant. Okay, so my discriminant, now I have to take it over to the table here, and it says if the discriminant is equal to 0, there is one real root. So this one has one solution or root. Okay, so if you remember, the roots or the solutions are the x-intercepts. Okay, you're going to do the same thing for numbers 34 through 36. Find the discriminant and then determine how many solutions there would be. So you would use the same equation and the same chart. Okay, so again, here's your classwork. If you feel like doing the challenge problems, you can. I will give you a big hint when it comes to number 41. It is a two-parter. So not only do you have to find the two solutions, but then you have to add them to the cost of the t-shirt to determine what the new prices would be. Okay, if you would like me to check any of these classwork ones, even though you're not turning them in for feedback, please feel free to take a picture of it or save it online and email it to me or share it with me through your drive. And I will check any answers you have before you try the exit ticket. The exit tickets are on Schoology, or you can also do them by hand or in a Word document and send them to me. But number 42 and number 43 need to be submitted to me for feedback.